very short video showcasing sometimes the problems you have when you have a lot of little subsystems all working in concert with each other. All I tried to do this morning was get my code to the point where I could walk onto a slanted surface, and if I sidestep either up or down to keep perfect contact with the surface. Before, what was happening was when I would step to the right, I would end up walking sideways and then falling down onto the surface. So there would be this sort of bouncing effect as I was going down. And in order to try to fix that, what I did was when I handle my collision detection, I start with my beginning position, I calculate the new position, taking into account acceleration from gravity, and then so I take that new position or take the original position and the new position, and then I just send that through the collision detection routine. And it handles the pathway as a straight line, despite the fact that gravity might have sent me through a curve, and it works well enough. I handle the collision detection at max 30 milliseconds at a time, with the expectation that my frame rate will be faster than that. What point was I getting at? So I use that travel vector as the straight line, and then when I detect a collision against a surface, I'll redirect that travel vector to take on the rest of the deflected travel path, which is how I get this deflection when I'm trying to move forward. The travel vector is just deflected along the normal of the surface that I'm colliding with. Now in the past, when I would jump onto this surface, the travel vector would be downward because of gravity. Well, when the travel vector then encounters the surface, I would slowly start sliding down. So the way I artificially handle that is if I know I'm colliding with a surface that is standable, where it's less than 45 degrees, I change the normal of collision to be perfectly vertical. That way I can jump and there's no deflection at all. And the problem that created was, well, okay, so I need to bring up one more point. So with that in mind, when I press in a direction and I'm calculating the new position that I'm going to take on, it no longer, when I'm standing on a slanted surface like this that I can climb on, I no longer calculate the new position as being directly beside me. I can do an adjustment where I try to keep contact with the surface by also adjusting my vertical position. That way the straight line travel vector sends me straight down the surface rather than sending me sideways so that I fall into it. And that worked fine for traveling up the surface, but when I traveled down the surface, there was still this problem where the microgravity that's trying to pull me down was still encountering a vertical collision vector to keep me from sliding down the surface when I jump straight up. That same vertical vector, when I'm traveling sideways like this with a micro drop, caused me to deflect to the left, which caused a bouncing effect as I was on my way down the surface. And that sideways deflection carried into the next iteration, where it worked it into the next position that I was calculating for collision detection, which caused me to be suspended above the surface and caused me to drop again. So there's a travel vector, but there's also a velocity that handles how fast I'm going downward because of gravity. And all that works together to calculate my future position so that I can run the collision detection. So I'm trying to think, how can I get these two systems to work properly together? And when I tried to get the velocity to be redirected properly down the surface, that just caused me to slowly slide down the surface when I was just standing still on it. So instead, what I finally decided to do was, if I land on the surface that I can stand on, that deflected travel vector, the same one that sends me sliding along a wall, previously that travel vector was being deflected, as I said, along that vertical vector which was sending me sideways. So I injected a little tiny bit of code where if I know that I'm colliding with a surface that I can stand on, I'll also, not only did I adjust the calculated new position when I was deciding what the full travel vector would be at the start of the collision detection, I also now apply that adjustment to the new travel vector that happens when I collide and it gets deflected. Both of those in combination now finally allows me to move up and down a surface without these little microfalls. When I first step off from the surface, there's a little bit of falling, but at least once you're in contact with the surface, you can move around it in any direction you want, and there's no microfalls and there's no bouncing. So it's just an example of how when you're trying to set up a collision detection system, you get these little subsystems working together with each other to try to give you a good result, but you end up getting this jankiness that you're trying to avoid. And something tells me that when it gets to the point where I'm actually climbing the steps and I'm stepping off of a step and going this way, I'm going to get those microfalls again. I'm going to do what I can to avoid that, but I'm not going to kill my head too much to try to solve it perfectly. I'll just get it working in the best way that I can, and then in the future, if I think of a better way of handling it, I'll try to do it in a way that's more reasonable, or that gives me a better result without having to chase my tail, trying to fix these subsystems that are working together to handle gravity and velocity and the travel vectors that are deflected during the collision detection. Anyway, I just wanted to bring that up as a point. The next step will be to turn this into a pill model where I have a sphere at the bottom, a sphere at the top, and a vertical cylinder. That way when I go against this wall, this bump will knock me out. And then after that, I'll get into crouching and ceilings and overhangs, and we'll go from there. Thank you for watching. I'll see you in the next video.